Okay, now for your part C. Part C, now I have moved the string from this place to here. Now some of the students will assume that string R will have the same tension as your previous question. Your previous question, okay, they may think that, oh, okay, I will have 100 Newton, but please take note, now the string has changed. PQ, this one is RQ. So actually I have given you a hint that the tension here would change. Now, let's say I didn't hint you. Let's say I still put string P. Will the tension be the same as previously? Okay, the answer is no. Okay, it won't be the same. Reason, the weight of, let's say I keep the weight of this beam the same between part B and part C. But because I move my string Q, the moment caused by this string and the moment caused by this string, okay, must be the same in order for it to balance, right? But now the distance has changed. This means that the tension in Q must be different. And because of that, okay, if this is different, therefore this one must be different as well. If not, your Newton's second law will not hold. Now, for those who are confused, what I mean is that in order for it to be balanced, F net must be 0 and M net must be 0, right? So F net, if you expand it out, basically it consists of the weight of the beam minus the tension in Q minus the tension in R, right? And they have to be 0. So if now your tension in Q has changed, your R must change as well, right? If not, you cannot balance off the W. Okay, so even if this is string P, okay, it will not be 100 Newton anymore. It will not be the same as your part B. Okay, now let's get back to what this question wants. So if you just want to solve this question, okay, you have two unknown. You do not know what is the tension in R, you do not know what is the tension in Q, but you know the weight of this thing is 160 Newton. And you want to find this guy, right? So where should you put the pivot? Well, the question has labeled the pivot here, but I have told you before, right? The pivot in your calculation is just a mathematical entity. So you can put your pivot anywhere you want. So since you are only interested in finding this is the other unknown that you don't really need. So therefore, you can declare the new pivot here, let's call it Y. Okay, so down here, you just need to take moment about Y. Okay, and then you just do your sum of moment clockwise equals to sum of moment counterclockwise. Yeah, and if you look at that, if you take your pivot here, basically you do not need to consider the tension in R anymore because the distance here will be 0. The weight of the beam will cause a clockwise moment. This one will cause a counterclockwise moment. So just substitute in accordingly. So this one is counterclockwise moment, right? So tension Q multiplied by the distance will be 1.8 minus 0.3. Down here it will be 160 multiplied by 1.8 divided by 2. So eventually just press your calculator, 160 times 0.9 divided by 1.8 minus 0.3. So you will get 96 Newton. Done.